Hello, my dear children. How are you all? Hope all are fine and doing well. Welcome to the 12th module of our chapter Magnetic Effects of Electric Current. Today we are going to discuss about domestic electric circuit, that is the circuit which we are using in our home. Here you can see the schematic diagram of a common domestic electric circuit. So we will start our topic. In our houses, we mainly use three wires in electric circuit. They are the live wire, the neutral wire and the earth wire. How can we distinguish these three wires? The live wire usually will have a red insulation and the neutral wire will have a black insulation and the earth wire will be having a green insulation. So by seeing the color of their insulation, we can understand which is the live wire, which is the neutral wire and the earth wire. Actually, the current from the electric poles is bringing to our home by the live wire. And after flowing through the entire circuit in our home, it goes back through the neutral wire. So actually, live wire and the neutral wire are completing or making the flow of current through the circuit inside the home. The earth wire is a protection for the house circuit. That means the earth wire is connected to the earth. So if there is any leakage of electric current, this current will flow to the earth through the earth wire. All the electrical appliances in our home are connected in parallel across the live wire and the neutral wire. The next video will give you a clear understanding about the three wires which we are using in our home circuit.
Here's a seemingly boring plug and a plug point, something that we see every day, right? But here's an interesting question. If you looked at your plug carefully, you'll see that the top pin is usually longer and thicker compared to the other two pins. Why do you think that is the case? Turns out that this can save us from deadly shocks. But how, you may be wondering, how can a little feature like making one pin longer can save us from shocks? Well, to answer that question, we need to explore what are the different wires that come to your plug point and what each wire does. So that's what we'll do in this video. We'll explore these three wires and then hopefully we'll be able to answer the original question. So let's begin. A wire that comes from one of these bottom holes, one of the wires will be insulated with red color and the other one would be insulated with a black color. The red wire is often called the live wire. So this is live, or it's also called the hot wire, and we'll see in a while why it's called that way. And the black wire is often called the neutral wire. So the immediate question could be, why are they having different colors and why are they named differently? What's the difference between the two wires? Well, when I first learned this, I thought that one of the wires brings the electricity to our house and the other wire, the black wire, will take the electricity back. And so this is how I should think. The electricity comes from, say, the electric poles to our house through the live wire, and it goes back through the neutral wire. Simple, right? But that doesn't make sense, mainly because we are not dealing with one directional current, right? Do you remember that we are dealing with alternating current? The current which keeps changing its direction. Once the current flows like this, then the current flows this way. So it doesn't make sense to say one wire brings in electricity, another wire brings out electricity, because the electric current keeps on changing its direction. So again, what's the difference between these two wires? Well, it turns out it's got something to do with voltage. If you look at this black wire, its voltage is always maintained very close to the voltage of the ground. And we'll see in a second what this really means, okay? And that voltage is often taken to be 0. And if you look at this live wire, it has a very high voltage. So this has high voltage. And the voltage difference between these two wires in India is often around 220 volt. If you're wondering why this particular number, it's got something to do with history and Edison and light bulbs and cost. We'll not get into that, okay? Don't worry about why it is 220. It just happens to be 220 for India. But again, what does that even mean? Well, that means if the current is flowing, say, in this direction, then this wire must be having a higher voltage compared to the ground. We usually call that as the positive voltage. But then, when the current is flowing in the opposite direction, then this should have a higher voltage, right? But its voltage remains the same. Now, the voltage of the wire becomes less than 0. It can become negative. And so that's when we'll have negative voltage. So the voltage of the live wire swings between positive voltage and negative voltage, making the current alternate, but the voltage of the neutral wire remains pretty much the same. And we can imagine this to be similar to a slide, one end of which is connected to the ground, other end is free to move up and down. So when the other end is up, notice the ball goes to the right, this way. And now if I move this end down, the ball comes back. So by moving that end up and down, notice above the ground, below the ground, I can move the ball back and forth, back and forth. So this end is like the live wire. Its voltage keeps going above the ground and below the ground, back and forth, making the current go back and forth. On the other hand, the other end is like the neutral wire. It's always having the same voltage as that of the ground. Does that make sense? So what does that mean now? This means that if, let's say, a cat comes and touches this neutral wire, and let's say the insulation is broken, right? Then what's going to happen to that cat? Well, over here the voltage is 0. Let me use white. Over here the voltage is 0. Even at the ground, the voltage is 0. Since the voltage of this is the same as that of the ground, there is no potential difference coming across the cat. And as a result, there'll be no current flowing through the cat. So the cat will not get a shock. But what if that same cat were to go and touch the live wire? Can you guess what's going to happen? The cat is going to have a very shocking experience, because now notice the live wire is either having a much positive voltage compared to the ground or much negative voltage compared to the ground, compared to the neutral, compared to the ground. And as a result, in either cases, charges will flow between the wire and the earth, resulting in the cat getting a nasty shock. And that's why that wire is called live or hot wire, saying that it's an extremely dangerous wire. Do not touch that wire. Now don't worry, no cats were harmed in the making of this video. Now, of course, this does not mean you go and touch the neutral wires. Definitely not, because this is in the perfect world. In reality, the voltage may not be exactly equal to that of the ground, so you might still get a shock. There can be faults and everything, so it's always dangerous to, play or touch these wires. I recommend not doing that at all. But in short, the live wire is at a very high voltage compared to the ground, but the neutral wire has voltage very close to that of the ground. Okay, if the two wires are enough to provide electricity, why do we need a third pin, right? To answer that question, let's attach something to this plug point. Let's attach a microwave, let's say. If you could look inside this wire, you would see something very similar. You would see two wires, one connected to the live, which is red, one connected to the neutral, and the current flows back and forth between these two. And this is the internal circuit of that microwave, which I've just shown as a resistor over here. And so you are right, only two wires are enough to run this microwave. Then why do we need a third wire? That is in case of a fault. Imagine when this microwave was installed in your home, some mishandling happened, and let's say the insulation of the live wire broke off and it started touching the metallic case, let's say. So here's the situation. Let me zoom in. So you can see the insulation has come off and the live wire is now touching the metallic case. Now, again, let's bring back our kitty. She's gonna have a bad day today. If I switch on the plug now, what do you think is gonna happen? Well, because the live wire is touching the metallic case and metal is a conductor, electricity will start flowing through the metallic case, through the cat and into the ground, again giving our cat a very, very nasty shock. That is extremely bad. We want to avoid that. How do we do it? That's where a third wire comes into place. There will be a third wire, which is usually green in color, which is directly connected to the metallic body. And it goes all the way to the plug, comes out of the third pin. Again, let's zoom out, comes out of the third pin. And then where does this wire go, you know? Let me get rid of that basketball. All right. You know where that goes? That wire eventually comes out of your house and eventually is, put inside the ground. And so this third wire is often called, no surprise, ground wire. This is the ground wire or the earth wire. It can also be called the earth wire. So how does that help? Well, now instead of the electricity flowing through the cat, that electricity will flow through this ground wire and go directly into the earth. Why? Why will it go through the wire and not through the cat? Well, because the wire has a much smaller resistance. This entire path has a much smaller resistance compared to the cat. And you might know already that electricity tends to flow through the smaller resistance path. So almost all the electric current will flow through that path, ensuring the safety of our kitty. So in short, if there is any current leaking due to any fault, the ground wire ensures that we don't get electrocuted. At this point, you might say, wait, a quick thing. Not all the plug points have a 3-pin, right? For example, mobile chargers and say my MacBook charger has only 2 pins. What's going on there? Well, that just means that the amount of current we are dealing with over there is so minuscule that even if we get a shock, it's not a big deal. So it's not worth investing in putting another pin. In fact, my MacBook does give me a shock every time it's charging. It's not a big deal. All right. So only when we're dealing with high currents, high power devices, that's when the third pin becomes super important. So with that, let's come back to the original question. Why is the top pin, which we now know as the ground pin, why is that always longer and thicker than the other pins? Can you pause and think about this? Well, if the ground pin is longer, that means when you're inserting, it's the ground pin that gets connected first, meaning our device is made safe first. And only then these 2 pins get connected, meaning only then the current starts running through this device to ensure that we will not get electrocuted in any case. And similarly, when you are removing the plug, again, we're ensuring that the ground is the last one to get disconnected. So we first disconnect the electricity from the device, and then we disconnect the safety, the ground wire. Ingenious, right? And of course, the ground pin is also made thicker to ensure that we connect the plug in the proper position. This way, there is no chance that the ground pin will get inserted into the live hole, which can again cause problems.
We generally use 2 safety measures in our electric circuits and for the appliances. The first one is the proper earthing with the help of earth wire. You have seen in the previous video that the metallic body of the devices are connected to the earth through the earth wire, which protects us from the electric shock. The second one is the insertion of electric fuse. Nowadays, instead of fuse, we are using MCBs, that is miniature circuit breakers. A fuse works based on Joule's law of heating effect. That is, if the current exceeds the limit due to the heat produced, the fuse wire will melt off and cut the electric circuit, which prevents the flow of electric current through the circuit. So a fuse wire should have a high resistivity and a low melting point. These two are the features of electric fuse wire. But I told you nowadays we are using MCBs. These are switches which automatically turn off if the current exceeds the limit. Now let's see one of the exercise question based on today's topic. What is the function of an earth wire? Why is it necessary to earth metallic appliances? The metallic body of electric appliances is connected to the earth by means of earth wire so that any leakage of electric current is transferred to the ground. That is, the earth wire provides a low resistance conducting path for the electric current. This prevents any electric shock to the user. That is why earthing of the electrical appliances is necessary. Earthing keeps the potential of the electric appliances to that of the earth, that is equal to zero potential. The next video will give you a clear understanding about the domestic electric circuit, the parallel connection of different devices in it, the precautions which we are including in domestic circuits such as earth wire, electric fuse, etc. So watch this video carefully.
In my house, there are two kinds of switches. One's used for low power devices like your TVs or mobile chargers or your laptops and everything. And the other one for the high power devices like your air conditioners or your refrigerators, your geysers and things like that. I'm pretty sure the same thing exists in your house as well. So the question that I always had is, why do we have two different kinds of plugs? Why can't we attach high power devices over here? It's advised not to do that, but why? Well, to answer this, we need to see the complete picture of how all these sockets are connected together. What is the kind of circuit that we have in our house, which looks somewhat like this. Whoa, that looks very complicated. So you know what we'll do? We'll start from what we already know and then build up from there. Okay, so we've seen that for each plug point, there will be 3 wires coming in. So 2 wires come directly from the mains. One is the live wire. Another one is called the neutral wire. I'm not going to write that because it's going to get crowded, as you've seen. And the voltage difference between them is about 220 volts in India. And of course, we have one more wire, which is a safety wire, which is called the ground or the earth wire. This wire carries any current that is leaking off from devices due to any faults, ensuring that we don't get any shock. So ideally, it's not supposed to carry any current. And we've talked about this in previous videos. So if you need more details, feel free to check that out. But the thing is, in our houses, we don't have just one plug point. We have many plug points and many devices. And all of them will have these wires coming out of them. And somehow all these must be connected together in some kind of a circuit. So the first question we want to try and answer is, what kind of connection do you think we'll be having? And again, to answer this, we can start thinking from what we have already seen. We've already seen 2 kinds of circuit connections that we can have. We can have a series connection and we can have a parallel connection. So, what do you think is the kind of connection in our houses? Do you think it's a series or parallel, or do you think it's a mix? Some are connected in series and some would be in parallel. Why don't you pause the video and just give this a thought? All right, if you've given it some thought, let's see. Let's start by exploring the series connection. The series is when you connect them end to end, right? Now, one immediate problem you can see over here when 2 plugs are, let's say, connected in series is that if you were to close one of this switch, let's say I put my mobile to charge over here and I close one of that switch, no current will flow over here. Why? Because this switch is open. See, this is one single wire. If you want the current to flow in this wire, then both the switches need to be closed. That means you need to switch on both these plug points in order for the current to flow. So either both will run or none of them will run. That's how series works, which means that's very inconvenient, right? I mean, I don't know about you, but I don't think I want my devices to work that way. I want them to be independent of each other. Does that make sense? And so if you consider that in mind, series is completely out of the option. So we cannot have any devices coming in series. So what does that leave us with? That leaves us with parallel connection. So the way we can connect plug points to make them independent of each other is we connect them parallel across each other such that each of the plug points are connected across the same points, the live wire and the neutral wire. So if you do it this way, notice now I can close the switch and the current will run through that, because this is one independent circuit. It's independent of these plug points and those switches. So parallel is how all the circuits are connected in our houses. And of course, they would have their own grounds as well. That's also super important. And by the way, if you're looking at this, you're wondering what this curve means. It basically, denotes that the ground and the live are not connected to each other. It's just a way of showing that they are independent wires. It shows that one wire is going above the other. That's it. All right. So this now might make you wonder, does that mean every single plug point in your house and all the fans and all the devices get exactly the same voltage? Yes, that's right. Every single plug point will get the same voltage. That's the defining feature, right? And how much is that voltage? As we said, it's about 220 volt, which is pretty high. And that's what makes these things dangerous. And this might make you ask another question. Well, does every single device require 220 volt? What about your phone chargers? Do they need 220 volt? Well, no. In such cases, you know what you will see inside those inside those adapters, you will see small devices called transformers that can reduce the voltage if needed. All right. You'll learn about them in higher grades and everything. Don't worry about them. Okay. The point is every single device, every single plug point gives you 220 volts, but not always. Ta-ta-ta. That's right. You don't always get 220 volts because there can be fluctuations. You might know about this. There can be, say, lightning strikes or short circuits or overloading, things that we'll learn about in future videos, of course. But because of all of these things, voltages need not stay the same. Sometimes you'll end up getting low voltage, in which case your light bulbs and your tube lights will glow a little bit less. Your fans will be working a little slower, which is a minor inconvenience, not a big deal. But what if sometimes you get a high voltage? That's also possible due to fluctuations. You might get, say, I don't know, maybe 1,000 volt, which is totally possible. What happens then? Well, then your devices will start drawing more currents if they are connected. And then your devices can blow up. That's one thing that can happen. But there are more dangerous things that can happen. You might know that if as the amount of current starts running through the wire, as that amount increases, the wire starts getting more and more heated up. And if this wire is not designed to handle that current, then that heating effect can actually melt the insulation, exposing the live wires, exposing these wires, and they can go and touch other wires and cause all sorts of problems. Another thing that can happen is if the heat is too much, it can even catch fire. That's just the worst. Which means to safeguard ourselves, let me just get back to normal. To safeguard ourselves from this dangerous high voltage fluctuations, we need to somehow make sure that if the current exceeds a particular value, then the circuit disconnects somehow. How do we do that? Well, you might already know about that. That's where a fuse comes in. So this is what we call a fuse. So what exactly is a fuse? So what exactly is this fuse? Well, a basic fuse is just a wire which has the ability to get heated up much quicker than the rest of the wires. So as the current starts increasing in value, the fuse wire starts getting heated up very quickly, and after a point, it's the fuse wire that immediately melts. And as a result, the contact breaks, and this ensures that the entire, the domestic circuit, the circuit in your house is disconnected from the mains. And that's how it ensures safety. And how do we build a wire like that? Well, what are the properties of this wire, if you're wondering? Well, a couple of properties, important properties would be, one, it needs to have a very high resistance compared to the rest of the wires. Why? Because a high resistance ensures more heating effect. We have seen that before, right? As the current flows through any object, if it has more resistance, it will have more heating. So that ensures more heating. And to ensure that it melts quickly, it will have low melting point. So it also needs to have low melting point. So with these two features, a fuse wire can be built to protect our circuits. And so now you may be wondering, what's the maximum current this fuse wire can handle? Well, that depends upon different kinds of fuse. You can manufacture different kinds of fuses, but the ones that, the low power circuits that we have in our houses, those fuses can usually handle up to 5 amps of current. If the current exceeds 5 amperes, that fuse will melt. So the idea is in this normal circuit, like where your fans and tube lights are connected, the current drawn is very low. That means if the total current exceeds 5 amperes, that means something unusual is happening, and that's why this is designed that way. So this is what we would call a 5 amp circuit. And of course, you may be wondering, hey, I don't see these fuses in my house today. Where are they? Well, today they have been replaced by these new devices called circuit breakers. They work on a very similar principle, but over here they don't melt. You don't have to change the wire every time a fuse blows up. They just disconnect automatically. Okay, a little bit more advanced, but the idea is the same. So let's not get into that. So perfect, right? We have the fuse to protect us from high voltages. We have the ground wires to protect us from some faults. Everything is fine, but there's one problem. What if I want to run my air conditioner and geysers and refrigerators and other high power devices? What will happen if I connect all of them and switch on all of them? Then together they will definitely try to draw more than 5 amps of current, and the fuse will blow up for no reason, right? This was not unusual. It's just that high power devices can't run on this particular circuit, which only limits to 5 amperes. So what do we do? What do you think we should do? Well, it's for that reason we will have a separate circuit for those high power devices. So that's why those plug points, which are responsible for, which provide power to high power devices, will have a separate circuit. So it'll also have its own live wire. It'll also have its own neutral wire. It'll have its own fuse. And we can now guess that this fuse can handle higher amount of current, right? So it turns out that this high power circuits usually handle about 15 amps of current. So anything above 15 amperes, then that fuse will melt. So in our houses, we will have two independent circuits. One is 5 amps and another one is 15 amps. And of course, they should also have their own ground. Ground is definitely required. So all these grounds will be connected together. So will there be only 2 circuits, or can there be more such circuits? The answer is you can have many more circuits, each one with their own fuse. It all depends upon where you're staying, how big the house is, or whether it's a factory or things like that. But usually they'll be having one 5 ampere circuit and one 15 ampere circuit. So how do we put this all together? I mean, there are only 2 wires, one live and one neutral, coming to the house. So how do we distribute it into different circuits? So the basic idea is we connect them all together. So let me show you. So we connect all the neutral wires together, and we connect all the live wires together after the fuse, and we put this in a box which is called the distribution box, right? Because it's distributing the incoming wires into different circuits. So let me just write that. This is called the distribution box. Distribution box. And then this wire can now go out of your house and then you connect to that electric pole, but your electric company needs to bill you, right? They need to know how much electricity you're using. It's for that reason it doesn't directly go, it goes through an electric meter. Again, something you may have seen. And the basic idea behind this meter is, at least the old ones, is that there would be a disk, and depending upon how much current you take, how much current you're drawing, the disk will keep on rotating, and then they will just calculate the total number of rotations the disk has turned, and that's how they calculate how much electricity you've used. And so from there, the wires will get connected to the mains through another fuse. You might be asking, why another fuse? Why not? Fuse is a safety device, right? So it doesn't hurt to have 2 levels of safety. This will again be a higher level fuse, higher amperage fuse. So definitely more fuses at more levels means more safety. And there we have it. This is how our domestic circuit looks like.